Alright, in this problem we've got Chris, and it says, while running a pass route in a football game, Chris runs 5 yards downfield. Chris then cuts in at a 55-degree angle for 3 yards, where he catches the pass. Next, Chris jumps 1 yard sideways to avoid a tackle, before running 12 more yards downfield for a touchdown. What is Chris's total displacement? And this problem came with a picture because some of those things he might jump right, he might jump left, we're not sure. So in the picture, it's kind of obvious for us. So let's look at this. We want to find his total displacement. So we need the magnitude, how far he went, and the direction for the shortest path traveled. So here he starts here, he ends up here, and the shortest distance will be a straight line. So draw the best straight line that I can here. Okay, from one to the other. When we were doing our other problems, it was nice because we had a right triangle and we could find the hypotenuse by just using Pythagorean theorem and then using a little trig to find the angle. This one, not so much. Okay, I still want to try to make a right triangle. That's my goal. If I can do that, I can find the hypotenuse. But I've got a lot of stuff here. So, step one, try to draw ourselves a right triangle. What looks like an easy right triangle for me is if I start up here by the finish and just come straight down, and then over at the start, come straight over to the right, I can make myself a 90-degree angle, and the green line will be the hypotenuse of this right triangle. Now the difficulty comes in trying to find the lengths of the two legs of this right triangle. So, some parts of the legs are pretty obvious. This part is 12 yards. We're given it. Okay? This part right here, the whole thing I'm not sure of, but I know this is 5 yards here, and if I go directly across, I'll know that this part is 5 yards. Because what I've just made right here is a rectangle, and the opposite sides of a rectangle are congruent. Okay, now what I'm missing is this piece right here. I'm going to go ahead and call that y because it's in the y direction. Sometimes you might have to use subscripts if there's more than one missing portion of this, but in this case there's only one, so I'm going to call that y. And then I'm going to look at this side over here. Okay, well, this is exactly horizontal. Bring it down. This right here makes a nice right triangle, a nice rectangle as well. So the opposite sides are congruent. So this portion is 1 yard. And now I need to find this portion, which I'm going to call x because it's in the x direction. Notice the y and the x are coming from this angled piece here. Okay? So I'm going to look at the angled piece. The angled piece, if I'm looking at it now, I get a right triangle. So what I'm going to do is find these missing sides of my right triangle. Now, there's a problem. I don't know any of the angles, but I could figure it out because this is going to make a 90-degree angle. So to find this angle that's in my right triangle, I simply am going to take 90 minus 55, and I will get 35 degrees. Now I just need to use a little bit of trigonometry to find these sides. So, it might help you to redraw this triangle off to the side. Some people might be able to do it right there, others might want to redraw. So I'm going to redraw this right over here. So I've got x, y, this was 3 yards, and this is 35 degrees. Not the most accurate as far as this looking like 35, but that's okay. So now I need to find these missing sides. So again, SOHCAHTOA. Little trigonometry coming into play. So here's my angle. Let's find y first. Y is opposite, and then what I know is the hypotenuse. So I come over here, opposite hypotenuse, I'm going to use the sine function. So the sine of 35 degrees is equal to the opposite, y, over the hypotenuse, 3. Multiply both sides by 3. 3 times the sine of 35 is 1.72. Next, let's find x. X is the adjacent side in relation to this 35 degrees. So I've got the adjacent, I was given the hypotenuse, adjacent given hypotenuse, we're going to use cosine. The cosine of 35 is equal to the adjacent, which was labeled as x, over the hypotenuse, which is 3. Multiply both sides by 3. 2.46. Going to go ahead and place these back into my picture here. So y is 1.72. X is 2.46. Which I can come down here, 2.46 yards. That was here, which is also there. Now I've got this nice big right triangle. I need to find the total length here, so 1 plus 2.46 is 3.46. That's the total x direction. Over here, I need to add everything up, so 12 plus 1.72 plus 5, 18.72. I need to figure out the hypotenuse. Okay, I'm going to call this direction D for right now. Okay, so to find the hypotenuse, I'm going to use the Pythagorean theorem. A squared plus b squared equals c squared. So 3.46 squared plus 18.72 squared equals c squared. So I have 362.41 is equal to c squared. Don't forget to take the square root of both sides. 19.04 yards. So his displacement, Chris's displacement, is 19.04 yards, and we are still missing one thing. We need his direction. So I'm going to go back over here. I'm going to label this angle as theta in the diagram. And I'm going to find that angle and then write it down over here. So, to find theta, I'm going to pick two sides. Doesn't matter which two, we've got all three. For now, I'm going to pick the two we just found. Okay? In relation to theta, this is the opposite, and this is the adjacent. So I'll use the trig function that has opposite and adjacent, in this case, TOA. So the tangent of theta is equal to the opposite, 18 7/72, over the adjacent, 3 46/100. To solve, I need to take the inverse tangent of both sides. Theta is equal to 79.5 degrees. So if we wanted to write it in a sentence, we could say that Chris ran 19.04 yards at an angle of 79.5 degrees downfield from a